So this is the question where we have to find the triplet. So we have found the pair, correct? Now we want to find a triplet in a sorted array. How can we? Okay. So what we want to do is, so this is the question. I want all of you guys to think. I think naive approach everyone can solve. Still, we'll write the code for this because it's important to know the naive approach as well, correct? I want everyone to give me the time complexity for this. So I want everyone to now to think of how you can solve this question using optimized way, correct? Okay, so this is how we got the answer. Anyone is having any confusion on this? Then we can discuss now. This is the question where we have to find the triplet. So we have found the pair, correct? Now we want to find a triplet in a sorted array. How can we? Okay. So what we want to do is, let's say we are given something like this: 2, 3, 5, 6, and 15. Okay. The value of our x is 20. We have to find a triplet whose sum is equal to 20. Correct. So the triplet will be, for specifically this example, will be 2, 3, and 15. Okay, this is a triplet whose sum is equal to 20. Now again, in this question, what we are looking forward to is to return a true or false. Again, we are not looking for any index or something. You just have to return true or false. If a triplet exists, return a true. If triplet doesn't exist, then return a false. Yeah, so this is the question. I want all of you guys to think. Is anything we can do on this question? What should be, like, for everyone who cannot think of at least the optimized way, I want everyone to give me the brute force approach. And if you cannot write the entire approach, and you can write, I think pseudocode will be just 3-4 lines. So I think it won't take more than 2-3 minutes. So please go ahead, guys, coding for it. We'll wait for 10 minutes at least for this so that everyone can code it. I think naive approach everyone can solve. Still, we'll write the code for this because it's important to know the naive approach as well, correct? You might think it's very straightforward, but sometimes you do small mistakes in implementing it. Then if you can solve through the optimized way, not through naive approach, it is very straightforward, clear that you guys are like, we are not understanding the question to the full. So it will give a very negative impact. So always, it will take 1 or 2 minutes only, but try to solve the naive approach also. So it will be an array, and it will take 3 elements. Okay, similar to what we did with pair, correct? Now we're running a loop. I equal to 0, y less than n, I plus plus. Similarly, for int j equal to 0, j less than n, j plus plus. For int, you have to find possible combination, correct? So we'll want to find all possible loops. Plus 1, and this will be j plus 1. And k is still less than n, k plus plus. If array of I plus array of j plus array of k equal to true, then we return a true. We're closing all the loops. Then we return a false. Okay. So guys, this is our code. So let's do a small diagram. Still, if someone is not clear. So this is it. 2, 3, 5, 6, 15. You have to find x equal to 20. What happens? Value of I is 0. Okay. Now for this 0, the value of j, let's say now is 1. And the value of k will be j plus 2, k will be 2. Correct. So we found the sum of 2 plus 3 plus 5. Very first iteration, it will be 2 plus 3 plus 5, which will be equal to 10, which is not equal to the given number. Then what happens? The value of k now, first the inner loop will complete. First, you guys can see this loop will complete, then this loop will complete, then this loop will complete. Okay, pretty straightforward. I'm going for very basic. So what we see now, the value of k now becomes 3. Okay. So this 2 will be there, 3 will also be there, but the value of k will now change. K will now become 6. So we sum this, it gets 11, still not equal to what we want. Value of k again changes. Value of k now becomes 4. 2 and 3 still they be same. Now it becomes, now 15 comes as the value of k is now 4. 0, 1, 2, 3, 4. Now becomes 20. So you can see here, guys, here we are getting the answer as 20. Correct. And what we return here the true. Let's say we found all the possible combination and still we are not able to get the answer. In that case, we'll return a false. Okay. So this is it. Yeah, anyone is having any doubt on this? How we are getting the solution? I want everyone to give me the time complexity for this. Cool. Fine, let's discuss. Okay, no worry. Let us see. Time complexity is n cube. Okay. See, you can see that here there are 3 loops, correct? 1, 2, and 3.
Yeah.
All of them are nested. If you see 100 numbers, what will be there? 1, 2, 3, 4, something like this. First combination with all of these, then second with all of these, then third with all of these. All possible combinations will be there, correct? Since these are nested, if it would have been 3 loops but not nested, it can be big O of n. But since you can see, I have closed the 3 braces, correct? All of these are nested. It can never be big O of n. You are able to follow why it is n cube? Cool. So this is it. So I want everyone to now to think of how you can solve this question using optimized way, correct? And some of you have already given me the correct solution. Those are good. Those are not given, you can use this time to think about it. It is pretty straightforward. Like, it is not even for triplet. If you have to found quadruplet or anything, you can use the same approach. So let's say you have 2, 5, 10, 15, and 18. Cool. You'll find a triplet whose sum is equal to, let's take for here the example 33. So we know the triplet will be 5, 10, and 18. Okay. So this is the, so we have to find triplet here. Okay. Now, what do you want to do? Most of you are given the answer in the very first go that fix the first index. Okay, so let's say we fix the first index and now we are finding the pair here. We fix the first index, what will happen? This 33 will come back to 31. Okay. Now we are seeing a pair whose sum is equal to 31 or not. So in this we will not find anything. Let's take some other example. Let's fix this 5. And now for this 5, let's see, is there any other pair whose sum is equal to 33 minus 5, which is 28. In that case, you will see, yes, there is a pair, and that pair is 18 and 10. So this is the idea. What is the idea? Fix one number and then apply the previous, then apply the pair approach. What is pair approach? 2 pointers. Let us see the code, then we'll do one dry run. So let us first write the triplet function. Takes an array, takes an n. Yeah, takes an x. Now what we are doing? We are running a for loop for int I equal to 0. As we have mentioned, this is the very first index, it will go to n minus 2. We do I plus plus. Now we have to find a function which is pair. This is pair is a function which is tell us whether there is a pair or not. And what we will give in the parameters is very important. If you see, we are giving the array, we are giving the n, we are giving x minus array of I, and then we are giving a I plus 1. If it is true, then return true. Else, or let us write for the whole loop. And outside this loop, return a false. This is the function. Inside this function, since we have made one more function, let's write that function as well. That function is also bool type because it return true and false. So is pair, we'll take an array, we take a n, we take a x, since our x value is getting modified in the code, and we take a starting index. Si is the starting index. Okay. So let's keep our I as starting index. That will be whatever is the new index. And we know our j will always be n minus 1 because we don't have to go to the last element because k is also there. So a better way, I think, is to, since we are applying a 2 pointers, correct? So it's always on the code like starting index and last index is always going to be the last element. So let's try a true pointer only. So let's write a while loop. While I is less than j. Simple code. If array of I, what you have written, array of I plus array of j equal to x, then you will return a true. Else if array of I plus array of j lesser than x, that means you need to increase the value of I. Else, always do j minus minus. We will close the while loop. Don't get anything, you return a false. Cool. So this is the code. What we have here is that we are trying to find a triplet. Correct. What is we are trying to do? We are trying to fix one element. So let us see by doing a small diagram. So let us say we have 2, 5, 10, 15, and 18. And similarly, we want to find 33. Okay. What we happened first? I equal to 0, I less than n minus 2, I plus plus. Correct. For I equal to 0, the is pair function is called, what values it will have? It will have the array Array is fine. So let it be array. It will have n, x and si. Correct. N is n will be 5. What is x? X was 33. But since we have already considered this element as part of our triplet, now we have to find the other pair. So it will always be 33 minus 2. So it will be 31. Okay. And what is the starting index? Starting index is always I plus 1. Why I plus 1? 1 second, guys. If we see here, so what we can see is that 531. And what is I plus 1? I was 0, so it will be 1. So if you see why the main concept is here only, why it is 31? Because we have already considered 2 as part of our triplet. So if you already consider 2 as part of a triplet, you will live with 30. You are left with 31, and 31, there should be another pair whose sum should be equal to 31. And what about this one? We have kept this one because we don't want to consider the first element. So we need to start from the second element. That's why we have considered this as 1. Now let's see. What happens when the value of I is 1? Value of I is 1. It is pair. It is pair. And here what happens is we take an array. Correct. We take an array. We take the elements, correct? So what is the 5? 5 is still the 5 because n is there same. Now the value of x, since the value of I is 1. So what will happen in another case when the value of x minus array of I is now 5. It will be 33 minus 5, which will be 28. Cool. And what the value of I now will be? This starting index, it will be 2. So you see here, what is significance of the starting index? Significance is pretty straightforward, that we want to start finding the pair from this point to this point. Now let's see for these, what happens in this is pair loop. Again, the same thing. I was less than j. What is I here? I is the starting index. The first case starting index I is 1. And the value of j is always going to be the last element. So 5 minus 1, 4. So it finds all the possible combinations, if you see here. So when 1 is less than 4, it says array of I plus array of j is equal to x. What is array of I? Array of I is 5. Correct. And j is 18. Sum will be 23. What is the updated value of our x? 31. What it is? It is lesser. We increase the value of I. I now becomes 2. J will remain to be 4. Because 10 plus 18, 28. 28 is still lesser than 31. Again, we'll increase the value of I. I now becomes 3. J still be 4. What happens when the value of I becomes 3? I now becomes 15. And when you do 15 plus 28, you will get something around 33. Correct? And this is 31. So this is smaller. When it is smaller, what will happen? This value of j will decrease. So I is 3 and j is also 3 now. So this loop will not execute anymore. And return a false from here. Return a false from here. So this is not true. It will go for one more iteration. As not as all the iterations. So this, if you see in the if condition, we have kept this. As long as if this is true, then only it will execute. Otherwise, keep on executing the loops. Now what happens in the second iteration? Similar thing, that we have the value of our, let's remove this, or let us write it down. We had 5, 31, 1. Correct. Array 5, 31 and 1. Sorry. We have 28 and 2. 31 and 1 we already did. We have 28 and 2. So for the first iteration, we saw that we didn't get the answer. Let's see we are getting the answer in second iteration or not. So let's say we have this 28 and 2. Now for the second iteration. Okay. We have this 28 and 2. What we see here now? The value of I is 2. The value of j will be n minus 1. J will still be 4. See guys, our starting index is getting modified. This is what the question is. Our starting index is getting modified. The I is equal to starting index, whatever we are getting from there. Since 5 is already considered to be part of the triplet, so that's why we are not considering, sorry, not this 5, but I equal to 1. That means 5. This 5. Since this 5 was already considered as part of this triplet, that's why we are starting from this index, n. Okay. Now when I is 2 and j is 4, what will happen? So let us make the array here also. 2, 5, 10, 15, 18. 2, 5, 10, 15 and 18. Okay. Value of I is 2. We have to make a pair whose sum is equal to 28. I is 2, that means it is 10. Okay. And j is 4, that means 18. Luckily, in the very first iteration, we got a number whose sum was equal to 28. And from here itself, we'll give a return a true. Once we return a true from here, this if part will give us a true. Like this if will execute and we return a true from here. Okay. So this is how we got the answer. Anyone is having any confusion on this? Then we can discuss now. Okay, cool.